All right, so today we're going to look at 8.2, which is our last law for solving triangles that don't have a 90-degree angle. And 8.2 is the law of cosines. So law of sines we used for three types: side angle angle, angle side angle, and side side angle. Which one of those three types is the one that you got to check for the no solution to solution? John?
Side angle.
So out of the five types that we're going to learn, side side angle is the only one that you have to ever do any of that for. The types we're going to learn today, you don't have to check for the two solutions. Okay? You still might have to check for no solution, but it's very, very easy compared to the law of sines one. But definitely two solution, don't have to worry about that at all. So the two types that law of cosines enables us to do, I might have mentioned them a little bit already, but does anybody have a guess what the other two types would be using the three letters? Yep.
SSS.
Yep. Side, side, side. So that's one type. And yeah.
Angle.
Well, what if I said to you, okay, I'm thinking of a triangle and the angles are 60, 60, and 60. How big is each side? Could you tell me?
Yes.
No.
Well, if you know it's 60, 60, 60, all you know is I'm thinking of an equilateral triangle. You don't know if the sides are 2, 2, and 2, or 12, 12, and 12. You can't solve a triangle if you don't have at least one side. Yep.
Angle, side.
Angle, side, that would be the same as this one.
Yeah.
So angle, side we can do, but we do with law of sines. Yep.
Side, angle, side.
Side, angle, side. You're like, well, isn't that the same as that? No. The difference with side, angle, side is the angle is between the two sides and not outside of them. And what ends up happening with these two cases is if you make a table using law of sines, you don't have a full row. Okay, with side, 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 you have something like this. You have three incomplete rows. Okay, law of sines isn't going to work. With side, angle, side, when you set your table up, you'd have something like this. You'll have two sides and an angle, but the problem is the angle is not in the same row as one of the other sides. So either situation you end up with, law of sines isn't going to work because law of sines means you pick two rows. Well, if you pick let's say you're looking at this example. If you pick the first two rows, you're going to be missing an angle and another angle. That's no good. If you pick the second two rows, you're going to be missing an angle and a side. You can only be missing one thing. And if you pick the first row and the last row, you're going to be missing an angle and a side. So no matter what combination of two rows you try to pick, you're going to miss two things at the same time with law of sines. Can't do it. Right. So that's where law of cosines comes in. So let's take a look at law of cosines. First of all, we're going to use that diagram to figure it out. And the law of cosines is based on the Pythagorean theorem. That's where it comes from. So ultimately, what we're going to end up doing is Pythagorean theorem on that triangle right there, because that's a 90-degree angle. But to do Pythagorean theorem, we have to figure out the lengths of these sides. Okay, so that's what we're going to try to do. So let me highlight, in different colors, the two sides we want to figure out. There's one. There's two. So what I've done first is I've labeled just the big triangle that we always would use with sides A, B, and C. So A is this long side on the left, C is the long side on the right, and B, just to make this clear, B is the entire length of the bottom. Okay. Y in this case, well, that represents just the height of the triangle. It's that line segment in green. And that line segment is perpendicular to B. So because it's perpendicular to the base and it goes to one of the vertices, that's the height. All right, so let's start with this line segment in red. Anybody have an idea how we could represent the length of that based on two things that are labeled up there? Yep.
B minus X.
Yeah. So the red line segment is B minus X. Now we have to figure out what X is in terms of this angle, right? So we'll figure that out in a second. And then what about the green line segment? How long is that one?
X.
I think I probably should use this color. This is just an indication for the bottom side. So the green line segment is the one that's the height. Yeah.
Y.
It's just Y. So now, can somebody set up Pythagorean theorem for me using, we'll call this triangle 1. How would you set up Pythagorean theorem using the sides from triangle 1? Yep.
Y squared plus B minus X squared equals C squared.
Y squared plus B minus X squared equals C squared. All right. So again, the only thing we have to do is you have to eliminate the X and the Y because you want to write them in terms of the sides and the angles in the big triangle. Okay, this is the big triangle that I'm drawing in blue. Because that's what you're going to be given when you do a problem. You'll be given things like A, B, C, alpha, beta, and gamma. They're not going to give you X, which is the distance from a vertex to some random point on a side. You're not going to get that when you do a real problem. And they're not going to give you the height of the triangle either. So we have to rewrite those two things. So let's start with Y. Okay, so let's find Y. And again, we're not going to get a number. We're just going to get a way to represent it in terms of the information in the blue triangle. Alphas, betas, gammas, things like that. All right. So let's see. How can we do this? Let's use this. We've got this angle, this side, and this side. What's the name of the side that we've labeled Y relative to gamma? Yep.
Would be the opposite.
That's the opposite. And what's the name of the side that we've labeled as A relative to gamma? Yeah,
Hypotenuse.
that's your hypotenuse. What two trig functions involve opposite and hypotenuse? Yeah.
Cosine.
No, not cosine. So
Sine.
sine. So to find a relationship between the three things that are circled, right, we're going to use sine. We are going to use cosine in a minute,
Yeah.
but that's going to be for x, right? And we're going to do y first. You could do x first. So let's set this up. Sine of some angle equals some fraction. What am I going to fill in for my angle? Yeah, Nick?
Gamma.
Gamma. Okay, so sine of gamma equals, and then what's going to be the fraction on the other side? Lindsay?
Y over A.
Y over A. Remember, the goal here is to get a formula for y in terms of the information from the blue triangle. So what would y equal? Yep.
A sine gamma.
A sine gamma. And that's all information that could be given to you in the problem. A is a side, gamma is an angle. So that's good. So in a second, we'll make that substitution for y in our formula in green. And you have to make a substitution for x as well. All right, so we've got find y. find x. So now, let's see, let me use a different color. You're going to use this, this, and that. Okay, A is still the hypotenuse, no change there. Gamma is still our reference point. But what is side x? What would be the name of that from the perspective of gamma? Yeah, ask it.
Adjacent.
That's adjacent. Let's put it over here. So x is adjacent. Now, what trig function would involve the adjacent side and the hypotenuse? John?
Cosine.
Cosine. So cosine of an angle equals a fraction. All right. Caleb, what's my angle here?
Gamma.
Gamma. Cosine of gamma equals. And what's going to be my fraction on the other side? Yep.
Y over x.
We're done with y.
Yeah. A over x?
Well, anytime you put hypotenuse in the top, now we're using one of those trig functions that's a little more popular.
Is x over x?
Yeah, adjacent over hypotenuse, so we're going to go with cosine. We don't want to use secant, cosecant, or cotangent. So x over a. And the goal, again, is to get a formula for x in terms of information in the blue triangle, information that you would actually be given. So what is x equal? Yeah?
Cosine A cosine gamma.
A cosine gamma. So now, it's just a matter of a little bit of algebra and some trig identities, and we're going to have the law of cosines. So we're using Pythagorean theorem as our base formula. Any questions on how we got what's in green first? Okay, now let's make some substitutions. Let's fill in this for y, and fill in this for x. Let's see what happens. All right, so y, I'm going to come down here so I have plenty of space. Let's see, y is a sine gamma. A sine gamma. And you're squaring that whole thing. Plus b, you're just going to leave that. Let's see, b minus what's x? A cosine gamma. A cosine gamma. What's that? And we're going to square that. Equals c squared. Nothing's really going to happen on the right-hand side. All the work in this is going to be on the left. Okay. This is easy to square. Okay. This is a product of two things and you're squaring it. It's just like you would square this. To square a product or raise a product to a power, just raise each factor to the power. So you end up with a squared sine squared. Okay. That's the easy one. So we have a squared sine squared gamma. Now, this is a binomial squared. How do you have to square a binomial? Like if you had x plus y squared, what do you have to do that? Yep. You have to FOIL that out. Okay? So you have to imagine b minus a cosine times another b minus a cosine. So when you FOIL it, you'd start with b squared. You would have b times negative a cosine, and when you do the inner, another b times negative a cosine. So you'd have two of those. Okay, that always happens when you FOIL something like this. So minus 2ab cosine gamma. And then the last part would be negative a cosine gamma times another negative a cosine gamma, if you were FOILing. Well, what's a negative times a negative? Positive. And it's a cosine gamma times a cosine gamma. So what would that be?
A cosine gamma squared.
Almost.
Oh, A cosine squared.
Yeah, just like the first one. A squared cosine squared gamma. Okay, and that equals c squared. All right, now there's some things here that are going to simplify a little bit. What I'm going to do, just so I have a little more space, I'm just going to take and copy and go like this. We're almost at the last step. Paste. Okay, I didn't need this part, that's fine. All right, let's rewrite that a little bit. What I'm going to do is I'm just going to take this term and I just want to move it up next to that one. If I was doing this, I'd probably do two things here, but let's just do that first. So a squared sine squared gamma plus b squared minus 2ab cosine gamma. Oh wait, I didn't move what I wanted to move. So plus a squared cosine squared gamma. I'm moving that next to it. So all I'm doing in this step is rearranging. That's it. Plus b squared minus 2ab cosine gamma. All right, now look at the first two terms. What do they have in common? Yeah.
A squared.
A squared. So when two terms have something in common, what can you do with that?
Factor it out.
Factor it out, and then watch what happens. A squared times sine squared plus cosine squared. So you have a squared times sine squared plus cosine squared, and the rest of it is just going to stay the same. In fact, the rest of it doesn't change for the rest of this problem. What happens here? Sine squared plus cosine squared. Nick?
It becomes 1.
That all turns into a 1. So what we end up with is a squared times 1, which is just what? A squared. So we end up with a squared plus b squared minus 2ab cosine gamma. And that is the law of cosines. Now there's 3 different ways you can write the formula. It all depends on what letter you put by itself on this side, but the pattern is the same in all 3 ways. One side squared plus the other side squared minus twice the product of the 2 sides times the cosine of the angle that's across from the letter you started with. That's the general pattern each time. So let's see if we can do it for b squared. What do you think the 2 letters I would put here are if I start with b squared? Yep.
It's
Yep. So a squared plus c squared minus what would come next? Yep.
Minus 2ac cosine beta.
2ac cosine of the angle across from the letter you started with. It's not a different formula, it's the same formula, you're just starting with a different letter. We can do it for a squared. I mean, you could do this for x squared, y squared, z squared. I mean, as many letters as you want to keep using. How would you write it if you started with a squared? Maybe.
B squared plus c squared minus 2bc cosine.
Yep. Again, it's important not to really get hung up on what letters you use. I don't really care about that. what I care about is you see the pattern. The sum of two sides squared minus twice the product of those two sides times the cosine of the angle across from what you started with. That's the pattern you want to remember. Because I may give you a word problem where the sides aren't labeled. Or maybe I label them with X, Y, and Z. So you don't want to get all messed up if there's different letters. Just remember the pattern itself. And that's it. That's the law of cosines. So there's really two different types of problems you do with law of cosines. Sometimes you're solving for a side. Sometimes you're solving for an angle. But that's it. Those are the only two different types of things that you'd ever have to do. Yeah, it's the same thing we just wrote down. You can put, if you want to put the letter by itself on the left, you can. We did it on the right. That's fine. And those are all your different versions of the formulas. All right, let's try an example. So we don't really need a sketch. I think we can tell it's definitely not law of sines. How can you tell that right away? John?
There's not a complete row.
Yeah, you don't have a complete row. So that means it's law of cosines. And it's not side, side, side. So it has to be the other one. It's side angle side. When you have side angle side, you are forced to solve for the missing side first. Because if you go back and look at, no matter how you write the law of cosines, the law of cosines involves every single side of the triangle every single time you do it. It always involves A, B, and C. You're already missing C, which means that's something that you're going to be missing in every version of the law of cosines. You cannot be missing anything else. So you have to use the version that's going to utilize the 42 degrees, which is this one. You have to do that one this time. All right, so let's set that up and see what we get. All right, so we've got a squared, and I do some of this as I go. If you want to write it out step by step, you can, but if you write every single step out, it starts to make for kind of a lot of writing. So you get a squared plus b squared minus, can somebody tell me what comes next? John?
2 times 4 times 7.
2 times 4 times 7 times the cosine of, what's the angle that we're using this time?
42.
The only angle we've got, which is 42. And what's that equal to? Yeah. C squared. So this is the type of problem where the variable is pretty much by itself. Yes, you're going to have to do the square root at the end. But overall, pretty much all the numbers are already on one side for you. All right, so let's just follow PEMDAS and add these things up. 16 plus 49 gives me how much?
65.
65. 2 times 4 is 8. 8 times 7 is 56. Cosine of 42 degrees equals c squared. Okay, now following order of operations, what would you do next then? You got to do the 56 times the cosine 42. Now this is where I guess you could type all this in at once in your calculator and just do the square root if we wanted to save a step. People okay if I do it that way? All right. And we're also not doing any rounding if you do it that way till the very end. So let's just write what we're going to do first, and then we'll type it in. So take the square root of both sides. And there's your answer. Square root of square root of 65 minus 56 cosine 42. That's exactly how you want to type it in. And your answer is 4.836.
How many decimal points do you want us to go?
We'll go the same we did with law of sines. We'll do the 3. 4.836. Now, let's take a second and sketch that. Let's see what's going on here. Remember the kind of triangle that it was originally. Okay, so let me put that information first. A, alpha, B, beta, C, and gamma. Just labeling the information I was given originally, you can see it was side angle side. But now you know C, 4.836. Besides being side angle side, that's what it was originally, what other kind of triangle is it now? Yep.
Side, side, side.
It's side, 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 which would still fall under a law of cosines problem. What else is it? Yeah?
SSA.
It is SSA. You can look at it a couple ways. SSA or SSA, however you want to look at it. You could look at it as an SSA. Now, SSA would bring you back to law of sines. But what's the problem with SSA? What don't we like about it? Yeah?
You can give us two different answers.
Yeah, if you try to do this or finish this with law of sines, now you got to worry about the two solutions and all that stuff. I'm not saying you can't do it that way if you're not careful with it, but it's easier to just finish this problem with law of cosines. Right, so we'll do law of cosines one more time, except now we're going to be solving for an angle. Again, law of sines would work if you are careful. Okay, so that was C. Let me just label this. This was to find C. Now, it doesn't matter. Do you want to do alpha or beta? Alpha. Okay, so let's find alpha. I'm going to move this out of the way. Yeah. And let's just write the formula down first so we don't forget what it is. Can someone remind me, what's my law of cosines that has alpha as the angle? John?
B squared plus C squared. Minus 2BC is and times cosine of alpha.
Yep, and what does that equal?
A squared?
A squared. Yep. Okay, so let's go through it. So B squared, we've got that. C squared, I can figure that out. 4.836 squared. Or can someone just tell me what 4.836 squared is? Probably about 23 or
23.386.
23.386. Now I'm going to need 2 times B times C. So if someone can do that, that'd be helpful. Well, 2 times B is 14. So I need 14 times 4.836.
$23.672.
23.672. And you did 14 times, I mean, that's almost 14 times 5. To me, I'm thinking that should be bigger than 23. Right? 2 times B is 14.
Yeah.
14 times almost 5.
Why would it be 14 times?
Well, it's 2 times B times C. That's the part of the formula we're on right now.
Yeah, I just did that.
So this is B squared, this is C squared.
I got,
So 14 times 4.836. Yeah?
you said 38.688.
So 14 times 4.836.
67.74.
Wait, why is it 14?
It should be a times.
Because 2 times 7.
It's 67.7.
14 times, oh boy, this is rough for everybody. 14 times 4.836. 6. Oh, it's a little hard. 67.704. Times cosine alpha equals, and a squared, we know that too. A squared, I think I can handle. Okay, so now this is the kind of problem where everything is pretty much on the wrong side. Okay, you want to get alpha by itself. Well, we want to start with getting cosine alpha by itself. So we have to get everything over to the other side. There might be some like terms we could deal with first. Does anybody see something I can do on the left-hand side first? Yep.
49 plus 23.
I can do the 49 plus the 23. Maybe. I don't know if I can really do it. 49 plus 23.386. Okay. 72,386. Minus 67,704. Cosine alpha equals 16. So what you have at that step is basically, if you want to look at it a little simpler, is like this. 72 minus 67 times something you don't know equals 16. That's basically what you're trying to solve right now. So what would be your next step in that equation? Yeah?
Subtract 72.
Subtract 72. You can't do 72 minus 67. For the same reason you can't do it right there. The 67 is multiplied by an unknown. That's not a like term with the 72. So we're going to minus the 72 to the other side, and then divide by the negative 67. So minus 72.386. That's going to cancel. If somebody can type that in for me, 16 minus 72,386.
56.386.
Sine alpha. And what is it?
56.386, or sorry, negative 56.386.
All right. One more step to get cosine alpha by itself, and that's to divide each side by the negative 67. At this point, I'm not going to do that out on the right side because I don't want to keep rounding it. So I'm just going to divide by negative 67,704. Negative 67,704. What I will do though is cancel out the negative because negative divided by negative is positive. And this is a good time to check kind of where you're at. You should always have a bigger number in the bottom. Always. Because we're about to do inverse cosine to get alpha by itself. To take the inverse cosine of something, it has to be less than 1. So if you don't have a bigger number in the bottom, you don't have a number less than 1 here. So the bigger number was in the top, go back. Something's wrong. So alpha is the inverse cosine of 56,386 over 67,704. And that, at this point, that's our final answer, so we do want to round that off. 56,386, 67,704. So that's an angle of 33,609. And that's alpha. And now beta is easy. We'll just add up and subtract from 180. But any questions on how we got alpha? So this is the kind of problem that combines both things that can happen with law of cosines. That's why I think this is the harder of the two cases, because one time you have to solve for a side, and then the other time you have to solve for an angle. So you have to do both. Right? And if we add these up and subtract from 180, does anybody have what beta comes out to? 104.3 what? 388. Thank you. Don't have to worry about two solutions, anything like that. In fact, anytime you're given a problem like this, it's always solvable. You can't make side angle side unsolvable. Just think about it. You're just being given a side, some angle, any angle you want, and then another side. You can always make a triangle out of that, because this angle can be anything you want, this angle can be anything you want, and the length of that side can be anything you want. So, I mean, the only way you could make this unsolvable is if you gave someone an angle of like 600 degrees. Well, then that's not a triangle. But side angle side is always solvable. Any question on that? Now, the other type, side, 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 might not be solvable. So the quick thing you want to check, you never have to check for two solutions, but you do have to check for no solutions. Check your sides and make sure that if you add any two sides together, it is bigger than the third. So 9 plus 7 is 16. That's bigger than 5. 7 and 5 adds up to be bigger than 9. And 9 plus 5 is 14, which is bigger than 7. So yes, this will have a solution. That's all you have to do real quick up front. Questions on what I just did there? Now, because you're given all the sides, you're never solving for a side. So you're not going to have to do this type of thing in this problem. We're going to be doing this type of thing twice. You have to do it a minimum of at least 2 times to get your angles. Can anybody think of a type of triangle where you would only have to do it 1 time? Yep. Well, with a right triangle, we could do it totally different. We wouldn't even have to use Law of Cosines. And you could use Pythagorean theorems. So that would be a little different. But how about a non-right triangle, where you would only have to do Law of Cosines 1 time, and you'd have all your answers for the angles automatic? Yeah? Well, equilateral, I can tell you all the answers right now, without doing anything. They're all 60. So if all the sides were the same, you could very quickly write all the angles. But we're close. What type of triangle would you only have to do Law of Cosines 1 time? Yeah?
Is it the one with 2 sides are equal?
Mm-hmm.
Scaling?
That's all sides are different. Yeah?
Isosceles?
Isosceles. Because if you have an isosceles triangle, so say it's something like this, and you know one of the angles in an isosceles triangle, you automatically know them all. Because if you know the one at the top, all you have to do is subtract it from 180, split the difference, and that's the ones at the bottom. If you know one of the ones at the bottom, well, then you automatically know this one at the bottom as well, because they're the same, and just add them up and subtract from 180 and get the top. So with isosceles, you could get away with only doing it 1 time. But scaling, you got to do it twice. Equilateral, you don't have to do it at all. And it doesn't matter which side you do first, because you know all the sides. So which angle do you want to do first? Beta. So let's find beta. And how does the law of cosines start out to find beta? Nick?
A squared plus c squared.
So I'm going to do that as I go. A squared plus c squared. Yep.
Minus 2ac
So 2ac, let's put that in. Yep.
times cosine beta equals b squared.
Cosine beta equals, and actually I know what b squared is, that's 49. All right, so let's go through it. 81 and 25, that gives me what, 106? Minus 2 times, let's do it this way, 2 times 5 is 10, 10 times 9 is 90. Cosine beta equals 49. All right, what's my next step? Yep.
Subtract the 106.
Yep, subtract the 106. And can you tell me what I would do after that?
You would divide by -90.
Yep, so I'm not even going to do 49 minus 106. I'll just leave it. But then I'm going to divide by the -90. And that would equal cosine beta. So I subtract the 106, divide by the -90. And what's my last step? Inverse cosine. So you can see you can really reduce the amount of writing in this problem if you combine some steps. If you don't want to, you don't have to. Alright, we'll see what we get. So inverse cosine of 49. If you're going to do it this way, you just have to be a little careful with parentheses, because I want it to do the 49 minus 106 first. Get that answer. Then divide that answer by -90. Then take the inverse cosine of that result. So, should get an angle of 50.704. So, any question on that, or any question on how you'd finish that up doing law of cosines one more time to get one of these other angles? Okay, so you just do law of cosines one more time, and then you'll have 2 out of 3 angles, and you can just add them up and subtract from 180. But if you have the time, and you want to be safe, you could do each one of these totally separate. The danger of adding them up and subtracting from 180 is if you get one of them wrong and you use it to get the other one, then that one's wrong. If you do what we just did here for each angle, you could get one of them wrong and then it would have no effect on the other ones at all. But it takes more time. So, any questions on that? All right. So, let's see. This one and this one. All right, so we're going to look, the last thing we're going to look at is 2 formulas for finding area of a triangle. Very simple formulas. But they're going to be based off the formula that you probably already know from geometry. And one of them is directly connected to law of cosines. We're not going to go through the proof of how you get the formula from the law of cosines because that one takes a little while. I'll show you one of the formulas for the area, but we're not going to do the proof of the other one. So here's your basic formula from geometry. The area of a triangle is 1/2 the base times the height. Well, that works great if you know the base and you know the height. But let's say you don't know the height. You're given a triangle like this. Say the base is 12. Maybe they give you an angle of 100 degrees, and maybe this side is 13. Well, that 13, that's not the height, because it's at an angle. So, how could we find the area of it? Well, we don't have to use law of sines or cosines. You could try to do something fancy to find the height, or let's look at what happens here. So you wanted to find the height of this triangle. And you want to represent the height in terms of this angle and this side. It's kind of like what we just did with law of cosine, but what's the name of the side that we labeled H? Yeah,
Opposite.
that's opposite. What's the name of the side we labeled C? Yep, hypotenuse. And what trig function involves opposite and hypotenuse? Sine. So the sine of alpha would equal what?
Each of its name.
Yep, and can you get each by itself for me?
C sine alpha equals H.
There you go. So that's a formula to find the height of a triangle without really having to think about it too much. You've got a formula right there, and we're just going to plug this part in right there. And that's going to give you a new formula for the area of the triangle. So it would be area equals 1/2 the base times the height. And the height is C sine alpha. So there's a new formula for the area of a triangle. 1/2 BC sine alpha. The 1/2 B is just from the original formula. It's the C sine alpha that now represents the height. And that's a pattern. Look at our kind of generic triangle. This would be alpha, beta, gamma. 1/2 BC sine alpha. Where is this angle compared to the two sides that you're using? John? It's right in the middle of them. So, what's another way you think you could write this formula? John? Nick?
1/2 AB sine gamma.
AB sine gamma. Yeah. I mean, you could write this an infinite number of ways depending on what letters you decide to label your sides as. The point here is it's 1/2 the product of two sides times the sine of the angle that's between them. That's the pattern. So let's not worry about writing it all these different ways. This is what you want to know. The area of a triangle can be found by doing half the product of any two sides times the sine of the angle between them. And what you're really doing is you're using trig to calculate the height of the triangle. You're just building it into the formula. So here's an example of where you could use that. We don't have to do it out, but can someone tell me how you would set up the formula using that idea to find the area of that triangle? Yep, so
1/2 3 times 12 sine 105.
1/2 the product of any two sides you want times the sine of the angle between them. And that's it. That's your area. So what's that going to be? 12, half of 12 is 6. 6 times 3 is 18. So that's going to be 18 sine 105. Just type that in on your calculator and see what you get. Oh, yeah, what do you get?
17.387.
387. Just remember it's an area. If I knew the label, I would put like square feet or square inches, but I don't know the label, so I'll just leave it. Now, that formula in and of itself, that is not connected to law of cosines. Right? So it's kind of like its own little thing. It's more connected to right triangle trick. This formula, which we're not going to go through the proof of, is connected to law of cosines. How you get this formula uses law of cosines. So that's the connection to what we're doing now and what we just did, this one. That is another formula for the area of a triangle. And notice there's no angles. So this is a formula you can use if you know all the sides of a triangle. Now, technically, you don't need this formula. It does make it a lot easier. But think about if you knew all the sides in a triangle, like this one, and I said, find the area. Well, If you use the formula I just taught you, 1/2 the product of two sides times the sine of the angle between them, you can find the area that way. The downside is you'd have to do law of cosines one time to get an angle first, if you want to use the formula I just taught you. If you want to be able to if you want to find the area of this triangle, and you want to avoid finding any angles altogether, you can. And you can use Heron's formula. Now, the A, the B, and the C, what are those?
Sides.
The sides, yes. S is something we haven't really talked about. But what do you call it when you add up all the sides in a shape? What is that? Yeah?
Perimeter.
It's a perimeter. Well, S is half of the perimeter, and it's called the semi-perimeter. That's why it's S. Again, S is a very, very simple thing to find. It's just half of the perimeter. And just magically, if you find half the perimeter, and you do half the perimeter times the semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C, and take the square root, you automatically get the area. And it's based on law of cosines. But we're not going to go through that. So 975, actually is that? Yeah, that's the same one we did. So we could find the area without Heron's formula right now because you know this angle. But let's pretend we didn't do that. We don't want to have to do that. Let's do it using Heron's formula. What's 9 plus 7 give me? 16. 16 plus 5.
21.
And half of 21?
10.5.
10.5. So the formula for the area, without worrying about finding the angle at all, is S times S minus every side. There's S. What's S minus 9?
1.5.
What's S minus 7?
3.5.
2.5. And what's S minus 5?
5.5.
5.5. That'll give you the area. We can just check what it is. Square root of 10.5, 1.5, 3.5, and 5.5. So the area should be 17,412. And all done without having to find any angles at all. So you have a couple different ways you can find the area of a triangle. This one being related to law of cosines. So that's the connection. All right. So that's the homework for tonight. Let me just double check that last question. And let's see. And you could get a no solution. Remember, you can only get that on a side. So check for that. But that's fine. So we'll take a look at that tomorrow, and then that kind of finishes the unit for the first half of the week, and then we'll look at what we're going to do the last